Alright guys and gals, this is your neutralization titration just in case you need this. So let me put this in slideshow for you. Alright, here you go. Hydrochloric acid reacts with potassium hydroxide. Okay, so I'm going to do this one for you, then you're going to do one. I'm going to do a titration for you, then you're going to do one. Okay, so HCl plus NaOH, don't forget, in a neutralization reaction we have equal amounts of H plus and OH minus ions. So on that pH scale, you're looking at the part where the H plus and that OH minus ion concentration are neutral. So if I have 50 parts, I have 25 parts of H plus, 25 parts of OH minus. Neutralization reactions, it's always acid plus base is going to yield a salt plus the water. Okay? So anion from the acid and the cation from the base form the salt. And remember, it's cation first. Anion's the last person to be picked for the dodgeball because they're grumpy. Anion, anti-negative. Okay? H plus from the acid and the OH from the base form the H2O. Okay? All right. So HCl plus NaOH is going to make salt plus water. So this is yours. Aluminum hydroxide is mixed with sulfuric acid. Go ahead and stop the recording. Figure out your answer. Don't forget to balance it. This one is tough. Okay? And I'll meet you in a minute. All right, the first thing you need to do, aluminum has a +3 charge, OH has a -1 charge. Crisscross to make you jump, jump. Sulfate has a -2, H has a +1, H2SO4. We know that the OH from the base and the H plus from the acid make your H2O. Okay? And then I am left with my aluminum from my cation from my base and the sulfate from my acid. Okay? So that's my negative, and I'm crisscross Al2SO3. But I'm not done yet. Here you go. So 2Al. So now I have 2 aluminums because I have 2 alumins on the other side. I have 3 sulfates, and then I have to have 12 H's over here because I have 6 from the 3H2SO4, and I have 6 from the OH part. So don't forget how to balance, guys. Do not forget. All right, moving on. Titrations. The whole purpose of a titration is to find the molarity of an unknown concentration. You may be finding the volume, etc., but the reason you titrate anything is to find the molarity. So typically what you're going to do is fill a burette of a base that is known, and you're going to have an acid in the flask below with some water and an indicator to figure out what the known concentration of the acid is, or the unknown concentration of the acid is. Okay? And we did that in class with the little titration and the endpoint. So let's do the first question together. A 14.84 milliliters of HCl solution of unknown concentrations is titrated with a standard NaOH solution. So this is your M of A, V of A is equal to M of B, V of B. All right. At equivalence point, so meaning at where I'm at concentration of H plus and OH minus being equal. Okay, and there's an indicator in there, so we know at the equivalence point where I have that light pink is being formed, we have 25 milliliters of 0.675 molar NaOH has been added. Okay, so now I'm trying to calculate the concentration of HCl. So here, I do not know M of A. So let's do this one together. Here's my equation, just so you know, it's balanced, we're good. I don't know M of A. V of A, do not forget, because it's molarity, okay guys, it's moles of solute over liters of solution, so you have to transform those milliliters. So my V of A is 0.01484 liters, okay? My V of B is 0.025 liters, and my M of B is 0.675 molar. That is of my NaOH solution. So, in order to get this to work, my answer that I got for M of A is 1.14 molar of HCl. You better put your answer just like that. I need the number, the unit, molarity, or liters, and what it's of. Okay? So in this case, it's MB VB divided by V of A to get M of A. And last one. A 10 milliliter sample of H2SO4 was exactly neutralized by 13.5 milliliters of 1.0 molar K of OH. What is the molarity of H2SO4? Go ahead and stop the recording and I'll answer your questions in just 1 second. All right, guys, so I don't know M of A. V of A is 0.010 liters. M of B is 1 molar. V of B is 0.0135 liters. So I simply take M of B, V of B divided by V of A and get 1.35 molar H2SO4. Please, please, please look at all of the work that we've done in class. Please know how to do a pH, a P of OH, an OH minus, and an H plus. Bye-bye.